Hello students, myself Suraj Gupta, an assistant professor in Mechanical Engineering Department at MLV Textile and Engineering College, Bhilwara. Today we are going to study the topic transmission of power. This topic is from the 4th unit of Basic of Mechanical Engineering course. So, first of all, we should know that why this power transmission is required. And we are talking about this power is mechanical power only. So for this transmission, we need motor and machine. Now, there are two reasons for which the power transmission is required. The first reason is if the position of this motor is far away from this machine, we need a power transmission system in between them. Second reason is if we need a different speed of the machine to be run from this motor, we need power transmission system in between them. So the power is depends upon the speed and torque, and this formula is equals to 2 pi n by 2 pi n t by 60, where n is the rpm means rotation per minute, and t is torque in newton meter. This torque can be generated at machine motor, that can be generated at machine. So we have the examples of power transmission from the motor to the winch. Here the power is generated at the motor, which is running at a higher speed, but the speed at winch is required very low because this load is lifted very slow. So the requirement of power system is to reduce the speed and to transmit the power at a certain distance. This example is an actual example, and ideal it is not ideal because there is a loss of the power because of friction. If this is a ideal power system, then the power at input is equals to power at output. There are several types of power transmission drives. The first one is the belt drive. In belt drive, we are going to see there are two components. First is belt and second is pulley. If we require to transmit a power from this point to this point, we need a pulley which is known as driver and need another pulley which is known as driven. This is known as input drive and this is known as output drive. And this will attach with the motor or engine, and this will attach with the machine which is going to run at a certain speed. So there are some certain notation which is d1 omega 1. D1 is the diameter at input, omega 1 is the angular velocity at input, d2 is the diameter at output, and omega 2 is the angular velocity at output. So there is a term which is known as velocity ratio is defined. It is defined as the ratio of the angular velocity of the output to the angular velocity of the input drive. So output to the input, but it is the ratio of velocities, angular velocities. Okay, so angular velocity is equals to 2 pi n by 60. So we have to remember this formula, omega equals to 2 pi n by 60, and d is already, I told you, this is diameter, and diameter and radius there is a relation, r equals to d by 2. Now we are going to define the velocity of the belt. This velocity of the belt, if there is no slipping, is denoted by Vb, and this Vb is every point on the belt is same. If the belt is going with a single velocity, because belt is a single material, so the velocity of this material must be same at everywhere. So here it is also Vb, here it is also Vb, here it is also Vb, and we can say that this pulley is completely attached with the belt and there is no slipping in between belt and pulley. So the velocity at this pulley is also Vb, and velocity of this pulley at this point is also Vb. But we know that a rotating body having a linear velocity also. So linear velocity of this pulley is r1 omega 1, and linear velocity of this pulley at this point R2 omega 2, which is also equals to the welt velocity. So the welt velocity equals to R1 omega 1, which is also equals to R2 omega 2 if there is no slipping. So there are two cases to find out the velocity ratio of simple belt drive. The first case is without slipping. The velocity ratio of the simple belt drive without slipping. For no slipping condition, we already read that Vb equals to R1 omega 1 equals to R2 omega 2. Omega 2 by omega 1 equals to R1 by omega R2. What is this term? Omega 2 by omega 1. This term is known as velocity ratio. Velocity ratio is the angular velocity at output to the input. Omega 2 by omega 1, which is equals to R1 by R2. So omega 2 by omega 1 can be simplified as 2 pi n2 by 60, 2 pi n1 by 60, and R1 can be replaced by d1 by 2 and R2 can be replaced by d2 by 2. So we have the formula for the velocity ratio equals to n2 by n1, which is equals to d1 by d2. And this formula is for without slip condition. Now we have the second case to determine the velocity ratio of the simple belt drive with slip condition. In slip condition, what will happen? This pulley will run by motor and the belt is run by the pulley, which is running at a certain speed, which is R1 omega 1, and this belt is going to slip in the anti-clockwise direction. This velocity is in clockwise direction, and if the slipping occurs, the belt will slip in the opposite direction. So the velocity of the belt will be decreased, and it is given that if the belt slip back on the driver pulley by S1% of V1, so Vb equals to V1 minus V1 into S1 by 100. So we can find out the Vb equals to R1 omega 1 minus S1 by 100 into R1 omega 1. This is equation number 1. So this belt velocity reduced to V1 minus V1 into S1 by 100. And this belt velocity is responsible to rotate this driven pulley. So this driven pulley, and there is a contact between the belt and the pulley, and this is the condition of with slipping. So slipping will occur here also. So which velocity is more? It is for pulley or it is for belt? Because of the belt is going to rotate this pulley, so velocity of the belt is higher than this pulley, and it is given that if belt on the driven pulley slip forward by S2% of Vb, that means V2 equals to Vb minus Vb into S2 by 100. So V2 means the pulley velocity is reduced by S2% of Vb, that is Vb minus Vb into S2 by 100, and this is equation number 2. Now we know that the linear velocity of the pulley at the outer surface where the belt is aligned is V2 equals to R2 into omega 2. V2 equals to R2 into omega 2, which is equals to Vb into 1 minus S2 by 100. This is equation number 2. This is equation number 2, and this is simply V2 equals to R2 omega 2. From equation 1, we can put the value of Vb in this equation number 3, we can say. So V2 equals to V1 into 1 minus S1 by 100 into 1 minus S2 by 100. And we know that V2 equals to R2 omega 2 and V1 equals to R1 omega 1. And the velocity ratio is defined by output angular velocity upon input angular velocity, that is omega 2 by omega 1. So omega 1 is going here and R2 is going here. So now we have the omega 2 by omega 1 is equals to n2 by n1, that is equals to d1 by d2 equals to multiply by 1 minus s1 by 100 multiply by 1 minus s2 by 100. So this formula is for velocity ratio if there is a slipping condition. Okay, if there is slipping at a driver pulley only, so S2 is 0. So we have the formula is like only this. if there is slipping at a driven pulley only, so this s1 equals to 0 and this term will be vanished. This term will be unity, means s1 equals to 0, so there is only 1, so d1 by d2 multiplied by 1 minus s2 by 100 only. So this formula can be used. So now we are going to do couple of problems. The first problem is very simple. Find the speed of the shaft which is driven with the help of a belt by an engine running at 400 rpm. The diameter of the engine pulley is 40 centimeter and that of the shaft is 25 centimeter. So we have to identify which is the driver and which is the driven pulley. So we can see that the shaft which is driven with the help of the belt by an engine running at 400 rpm. So this engine is going to run this driven shaft. So this engine is driver, means n1 equals to 400. The diameter of the engine pulley means driver diameter is 40 centimeter and driven diameter is 25 centimeter, and we have to find out the speed of the shaft which is driven. Okay, so we have to find out n2. So given that d1 equals to 40 centimeter, d2 equals to 25 centimeter, n1 equals to 400 rpm, and n2 is to be find out. From velocity ratio formula, n2 by n1 and d equals to d1 by d2, so we can easily find out the value of n2, which is equals to 640 rpm. Now we are moving for the second problem. Is a shaft is running at 350 rpm to drive a parallel shaft at 700 rpm. The diameter of pulley on the driving shaft is 50 centimeter. Then calculate the diameter of the pulley on driven shaft if there is no slipping and if there is slipping of 20% at driver and 30% at driven shaft. So first of all, we have to identify which is the driver and which is the driven shaft. So driver shaft having the speed of 350 rpm and driven shaft have the speed of 700 rpm. The driving shaft diameter is 50 centimeter and the diameter of the driven shaft is to be calculated. Okay, so the given data are n1 equals to 350 rpm, n2 is the 700 rpm, and d1 equals to 50 centimeter and d2 is to be calculated. For case A, if there is no slipping, we have the simple formula, that is n2 by n1 equals to d1 by d2. So d2 equals to n1 by n2 into d1, and d2 can be easily find out to be 25 centimeter. Now we have the case B if there is slipping condition. In slipping condition, we have the S1% means there is slipping of 20% at driver, that is S1, and at a driven, that is S2. So S1 equals to 20% and S2 equals to 30%. So we have the formula for the velocity ratio, that is equals to n2 by n1 equals to d1 by d2, and these are the slipping terms, which is 1 minus s1 by 100, 1 minus s2 by 100. So we can easily find out the value of d2, which is equals to 40 centimeter is calculated. There are two types of arrangement in simple belt drive. One is open belt drive and second is cross belt drive. In open belt drive, belt proceeds from top of one pulley to the top of another pulley. In cross belt drive, the belt proceeds from the top of the one pulley to the bottom of the another pulley. In open belt drive, the driving shaft and driven shaft, are rotating in the same direction. Means if it is the clockwise direction, so the driven shaft is also rotating in clockwise direction. But in case of crossed belt drive, the driving shaft and the driven shaft rotate in the opposite direction. If it is the clockwise direction, so the driven shaft will rotate in anti-clockwise direction, because if the driver pulley is rotating in the clockwise direction, the belt will move in this way, so that the driven shaft will rotate in anti-clockwise direction. So on the basis of requirement, we use the different arrangements of the belt and pulley. I'm at home and it is to be submitted by 2nd April in the PDF format at Google Classroom. These two problems is to be solved, and you have to write your name and roll number on your answer sheet, which is going to be submitted on the Google Classroom. Thank you.